Okay, one more time. When we have two equations, two linear equations, that means we have two lines. First scenario is we have exactly one solution because those lines intersect. What that means is this point works in both this line and this line. Kind of like those absolute value equations we did where it had the and statement. It has to work in both of the equations. So intersecting lines, exactly one solution. Second scenario, we have no solutions. Okay, and think of this as well, when they intersect, they have one. So the way they have none is not to intersect. Well, we could always do that by having parallel lines, right? Where they never intersect. Okay, parallel lines, no solutions. And the third scenario, you guys all remember this from Algebra 1. The third scenario was infinitely many. Infinitely many solutions. I always abbreviate solutions, SOLN. Okay. Infinitely many solutions. Well, when that happens is when every point on both lines both lines are intersect. So the only way I can do that is if I have one line on top of the other. So there's one line. There's my second line right on top of it. See how every point intersects. So if we get that case, we have infinitely many solutions. Now, again, let's go back and think about this a little bit. We get the visuals from the geometry visuals of two lines. Algebraically, what we're going to do is we're going to solve these two equations. Well, one way is graphically, that's the visual. We graph these lines and see if they intersect parallel or infinitely many. They lay on top of each other. Now, on the back, you don't have a graph. You're going to be solving these equations algebraically. So we need to know what this looks like algebraically, each one of these scenarios. Well, for the first one, when we have exactly one solution, you're going to get x equals a number or y, depending on what variable you solve for. Then you plug that number back in, solve for y. So you get one ordered pair. Makes sense. That's a point. It's got to have an ordered pair. Algebraically, you're going to solve the equations and then solve for one variable and then solve for the other variable. That's how you get your x and y. When you get a no solution, well, you're going to get, when you do it algebraically, you're going to get a situation like an untrue statement, like 0 equals 3 or 5 equals 6, something that's not true. Okay, this is the algebraic. Then, if it's not true, you know that you have parallel lines. Now, infinitely many solutions, when we solve that algebraically, you're going to get a true statement. The variable is not going to be solved for. You're going to get something like 0 equals 0, 2 equals 2, where there's no variable but a true statement. Okay, so these are the algebraic ways that we're going to solve, that you're going to notice. Okay, so the first method is by graphing. And again, That's by actually visually seeing the lines. So we need to graph each one of these lines. And that's why we had one of those sections. We actually had a quiz on reviewing lines. So I'm going to graph this line first. It's linear. All linear equations can be put in the form of y equals mx plus b. Make sure it's in that form because that's the easiest way to graph a line. Okay. In this situation, my b or y-intercept is -2. My slope is 1/2. So to do this, you need to graph this line. So my y-intercept, or where it crosses the y-axis, is -2. And I need another point here, so my slope will go up 1 and over 2. Now, graphing is not the most accurate way of getting a point, a solution to systems of equations. So I highly suggest here using a straight edge. Okay. Because if these lines don't intersect at a, at a grid where the grid lines cross, it's going to be extremely difficult to figure out, what the solution is, if it has one. Okay, let's go ahead and graph line number 2. Here, my y-intercept is +3. My slope, see, I got a -2, and we're going to make it a fraction, so I can draw my line. Okay, so I start at 3 on the y-axis, and this time, you can put that minus sign with either one, 2 or -1. I'm going to use the -2 because I want to try to get close to this line. So I'm going to go down to the right 1. I'm going to keep going because I can get an exact location where they intersect. Down 2 to the right 1. There's my intersection point right there. So they do intersect. At the point 2, -1. That's my answer. Any questions? If you have any questions, unmute your mic and ask, or put them in the chat. I'll put the chat up for myself. Okay, number 2. All right, I'm going to graph this line. They're in y equals mx plus b, so that's good. So my b is 2. My slope is 2. I'm going to make it a fraction. So I'm going to start at 2. I'm going to use -2 over -1. See, I'm going to go down to the left 1. Down to the left 1. I could have gone positive, but I think I'm going to be more accurate if I did the negatives. Let's see. All right, graph the other one. Y-intercept is 4. And again, my slope is 2 over 1. So here's my 4. And again, I'm going to use -2 over -1. -2, -1, -2, -1. Look what happens here. -2, -1. I end up with parallel lines, right? Now, don't just leave it like this. Please put down no solution. These are the actual answers. Okay. Real quick, number 3. When I have x equals a number here, what kind of line do I have? It's a vertical line at x equal 1. So here's x equal 1. Vertical line. Remember, there was a slide presentation on the grade tracker sheet for that. Now this equation, I'm going to have to solve for y, put it in y equals mx plus b. So I have x minus y equal 3. I have to get y by itself. See how these are y equals mx plus b? Y is by itself. So I need to subtract x from both sides. I get negative y equals negative x plus 3. Don't combine those. Then I have to divide. There's a negative sign with the y. I'm going to divide each term by negative 1. Okay, that gets rid of my negative sign. And I get y equals negative x over negative 1 is just positive x. Positive 3 divided by negative 1, negative 3. So here's my b, negative 3. Now, what's the coefficient of x here, my m? Well, it's 1. I have 1 over 1. So let's graph this line. Y-intercept, negative 3, up 1, over 1. There's the intersecting point right there. So my solution is positive 1, negative 2. Let's do one more. One of these were a tricky one. I can't remember. It must be this one. Okay, we got to solve these for y. I have x plus 2y equal 4. Let's see, going to subtract x from both sides. I get 2y equals negative x plus 4. This time I have to divide every term by positive 2. So I get y equals, now don't forget there's a 1 here in front of the x. So my coefficient for x here is negative 1/2. That's my m. Okay. My x is in the numerator, so I can pull it out to make it look like y equals mx plus b. Positive 4 divided by positive 2, positive 2. This definitely was kind of a trickier one. My b, positive 2. My slope, now you can put the negative with the 1 or with the 2. There's my line. Positive 2, where it crosses the y-axis. I'm going to try negative 1 to the right 2. All right, 2. Or maybe I'll put a couple points with using this one. Up 1 to the left 2. up 1 to the left 2. See, no matter which one I use, I get the same line. It should be on the same line. Okay, now I got to solve for y in this one. So I'm going to put it down here. Let's see, let's try a different color. 3x plus y equals -3. This one's not too bad. It's only a one-step equation here. Subtract 3x from both sides to get y by itself. I get y equals, don't combine those, -3x minus 3. So here, my y-intercept is -3, and my slope, that's a whole number, so I'm going to make it a fraction. Either -3 over 1 or 3 over -1. So I'm going to start at -3. And I'm going to use this one. Go up 3, 1, 2, 3, to the left 1. Up 3, to the left 1. There's my solution right there. Exactly 1 point, -2, +3. So there's the first method. Okay. Solving by graphing. Now you've got 2 more methods here. We've got, if you remember, we've got substitution, and I'm not going to do all these. Okay. Where the first step here, important, is get or solve a variable by itself. Variable by itself. Now, the first one's pretty easy because not only do I have one equation with a variable by itself, but I have both equations. Since they both equal y, I can set these equal to each other. 5x plus 23. See how that equals y? So does this. So these must equal each other. Think back to your geometry days. A equals B, B equals C, then A equals C. And solve for x. Okay, I like keeping my variables positive. I'm gonna add 7x to both sides. 12x plus 23 equals -13. Subtract 23. I get 12x equals -36. Divide both sides by 12. And I get x equals -3. So this is where students say, oh, okay, I solved it. I got a solution. Must be 1 point. No, we got half the point. We got x equals -3. Remember, this is an ordered pair. I have x. Now I got to get y. So I need to go back, pick either one. I don't care. I'm going to pick this one. Y equals 5. I'm going to substitute in what I already know for x, which is -3. I have -15 plus 23. So I know that y equals +8. So there's my answer. Now you could go back and check to make sure it works in the other one. It's up to you. Let's do let's do number 7 underneath it. Okay, first thing I have to do is get a variable by itself. Actually, let's do number 8. Number 8's a good one. Now this one doesn't matter which one to get by itself. You can pick either equation and you can pick either variable. I'm going to pick this top equation. -6x plus 3y equals -9. And the variable I want to isolate. I want to isolate the y. So I'm going to add 6x to both sides. I get +3y equals 6x minus 9. Then I'm going to divide. I have to divide that y by 3, which means I have to divide each term by 3. I get y, 6 divided by 3 is 2x, -9 divided by 3, -3. Okay, so I have a variable solve for this equation. But what I need to do is take the other equation, 7x minus 5. I know what y is. So I'm going to substitute in what I know, what y equals. And that's 2x minus 3. I have to use another color. I'm going to substitute that in for my y. Okay. 2x minus 3. Now I'm going to solve for x. And this is a little bit harder. 7x. I have to distribute the -5 times 2x is -10x. -5 times -3 is a +15 equals 21. Solve for x. 7x minus 10x, -3x, plus 15 equals 21. Going to subtract 15 from both sides. They get -3x equals 6. And then divide both sides by -3. I get x equal 2. So I know this is exactly 1 point solution. Got to find y. X is 2. Pick one of these, either one. I'm going to pick the bottom one because I used the top one. 7, I know x is 2 minus 5y equals 21. Solve for y. 14 minus 5y equals 21. Let's see, subtract 14. I get -5y equals 7. And then divide both sides by negative 5. I get y equals negative 7/5. Second method, substitution. And then the third method, elimination. Elimination, you're going to add the two equations together to eliminate one of the variables. So add equations to eliminate one of the variables. Okay. So if it doesn't eliminate one of the variables, you have to make it that way. For instance, well, number 9, if we just add these two equations together, we're going to go ahead and eliminate one of the variables because the x's will cancel out. 5y plus negative 3y, 2y, negative 5 plus 3 is negative 2. Divide both sides by 2. And I get y equals negative 1. Now, don't forget to go back and figure out what x is. I'm going to pick the top one. 9x plus 5. My y is negative 1 equals negative 5. 5 times negative 1 is negative 5. Add 5 to both sides. 9x equals 0. So we know that x is going to equal 0. Okay. Now, it might be as simple as multiplying one of the equations. If I multiply, look at that number 10. If I add them, nothing will eliminate. But if I multiply the entire second equation by negative 1, I get negative 10x minus 5y equals negative 15. I'm going to rewrite the top one, 10x plus 5y equals positive 15. If I add those together, these eliminate, these eliminate. I'm going to have to put a 0 there. 15 plus, or negative 15 plus 15, 0, 0. Remember, when I get this situation, this is always true. So this is infinitely many solutions. If I got like 2 equals 0, it would have been no solutions. Sometimes they get a little tricky. Number 12, if I add these together, neither of the variables is going to eliminate. If I multiply one of the equations by a number, they're still not going to eliminate. What I like to do is, first of all, I look for a variable with different signs because that's always easier. But I'm going to try to get rid of my x's. This is what I'm going to do. The top equation, I'm going to multiply because I'm trying to get rid of the x's by the coefficient for the x, which is 6. The bottom equation, because I'm trying to eliminate the x's, I'm going to multiply by. Now, I'm not going to change the sign because I want one positive, one negative, so I'm just going to use positive 7. Okay. So distribute, and at least I know the x's will eliminate. So the top one, I get negative 42x 6 times positive 3y is 18y. 6 times 19 is what? 54, 114. 7 times 6x, positive 42x. Do you see how those are going to eliminate? 7 times 5y, positive 35y. And then 7 times 14 is 98. These eliminate. I get 53y equals 12, 21. And I'm assuming that's going to divide equally 4. Yep. Pick one. I'm going to pick the bottom. 6x plus 5. My y is 4, equal 14. Solve for x. 6x plus 20 equals 14. Subtract 20. I get 6x equals negative 6. So x is going to equal negative 1. Answer, negative 1, comma 4. Okay. A lot of stuff going on with these three methods. In Algebra 2, we usually teach them and review them all together because you've had a whole unit on this in Algebra 1. If you have any questions or problems with this, please, by all means, I leave the Google, like I said, I leave the Google Meets open for quite a while. You can always come back on. You can always use the Math Tutoring Google Classroom. All you have to do is join the link, and I have that information on our Google Classroom, and then just click the link, and there'll be a teacher there. Questions, comments, concerns? I know it's a long note lecture section, but I wanted to go over a lot of the problems. Thank you for hanging in there. If not, you guys are free to go.